Hello friends, this is Sasha with Harmony Air. I would like to share with you one of our latest installations of a solar with backup systems for a commercial site. This is a relatively large installation. We have two large ground arrays. Um, we have approximately 90 kilowatts worth of ground mount solar array connected to two systems. One a Solar Edge with LG battery backup, and another one is Solark with Discover batteries. All the solar panels got Tigo optimizers for control and monitoring. This entire commercial facility is being fed by this 320-400 panel. So Solar Edge is taking care of a couple loads on a facility, and the solar backup system is taking care of the most of the loads. We do have also a generator backup. We set our batteries to discharge down to 10%, and then the generator will come on through the transfer switches to supply those different loads. Now we're gonna go into mechanical room. This is our mechanical room. We have what we're seeing here is a grid distribution panel. This panel is supplying each one of the Solark inverters. We have 5 Solark inverters, and number 1 is the master. So this panel distributes, connects grid to each one of the Solarks. So when Solarks are producing power from solar, we're able to sell this power back to the utilities, to PG&E, or at night when there is no solar, if we need to recharge the battery, then we would draw power from PG&E, from the utility, and charge the batteries and provide energy to the loads. In case there's a power outage, the Solarks will use the battery energy stored in the batteries and send that energy to the load. We also have a bypass breaker over here, and I do it practically on all our installations. I highly recommend that, because inevitably maintenance will be required. System might have some kind of shutdowns for firmware updates, or due to some malfunctions, and specifically on big commercial facility that is sensitive to power losses. We don't want to have a situation where it's Friday night or any night and they have no power. So the maintenance people here are educated how to bypass the entire backup system. One very important thing, it's a recommendation to anyone who is doing Solarks, or for that matter any backup systems, but make sure that you create some kind of a mechanism. In our case, it's this plate that prevents the accidental turning of the bypass switch while the load breakers are on, because that's what, if we have the bypass switch on, if the bypass switch is on while the loads are on, the power from load will go back through the bypass into the grid supply, and it's going to create the loop which will damage the inverters. It could just shut them down, but there is a very good likelihood that it's actually going to do damage to the inverters. So if we want to go into the bypass, we must turn load off coming from the inverters, so we don't create this loop, and the inverters don't damage themselves. It's like shorting the inverters really quite badly. So we covered the grid supply. Like I said, this is our load output. So this is a combiner panel. Each solar converter supplies each one of those breakers, and all that energy is being combined together, and it's going through this main 200 amp breaker, and then it goes to the loads in the main panel. And then we have the last panel is the generator distribution. So we have a generator, I believe it's around 60 kilowatts, and when the generator comes on, our batteries are set to discharge down to 10%. Those are lithium ferrum phosphate, so no problem discharging them, and it will be a very rare thing to happen. But when the generator comes on, the power will come into this panel through the main switch, through the main breaker, and then each inverter has its own breaker in this panel, and so each inverter is getting power from this distribution panel. What we have over here is a Midnight Solar battery combiner, and we have 10 Discover batteries. So each battery has its own breaker, 125 amps. So if we needed to work on any of the batteries, we can isolate them and work safely. We also have breaker per inverter. That's an inverter supply. So each one of the Solarks have their own breaker in case we needed to do maintenance and we needed to isolate the breaker from the system. We won't need to turn the entire system off. We can just turn one at a time. This is one of the Solarks, Solark 5. It's here by itself because we didn't have space for all 5 in one place. So now we're gonna go inside this mechanical room, and over here we can see our Solarks. This is master. So all the programming and happens through the master, and we can go over here to the settings and click the wrench, go to the basic setup and parallel, and we can see it's set up in parallel, master 0, 1. So that's inverter 1. 2, 3, and 4, and the 5 is in another room. We have Discover batteries on this side. Those are 6.6 kilowatts energy, so 6.6 thousand. So we have a total of approximately 70 kilowatts of Discover battery storage. This is our Tigo CCA unit. So all the programming, monitoring, and control of the Tigo optimizers are happening from here. As few things that I learned from this installation, since it's a really big installation, very demanding. One of the things that I learned is, as you can see over here, this is the output to the loads. So while each of the Solarks is actually rated, you can see the rating over here. The continuous AC pass-through power is 63 amps. What happens, because we have multiple units stuck together, they're using software to balance the output to the loads. So this one right now is only doing 2.6. This one 2.65. This one is 2.66. Number 3 2.4. So it's not the same. It's not exactly even. Number 4 2.34, 33. So you can see there it's not the same. 2.6, 2.33. It's not a problem. It's not a problem at all when we have small loads. The problem can happen, and we observed it on this side, is when we get to the limit of those inverters. Let's say there's a very high demand, very high load on the system, and let's say we're pulling towards the load 7 kilowatts on each inverter. Let's say it's within the range, it's fine, it's not a problem. But then suddenly a very high load comes on, and the software needs time to distribute it evenly between all the inverters. And it doesn't happen instantaneously. It takes a little bit of time. It could take, there is no specific time stated how long it will take, but it definitely takes time for the software to distribute it evenly. But if that load is really high, it can overload that one or two inverters. So one of the inverters will kind of get hit by a higher load. Now if that inverter gets overwhelmed, it will go into an error, a high current, and that inverter will shut off. When that inverter shuts off, that load, that high load, begins to it's like a domino effect. Now let's say we had 4 inverters, and that's what we had 4 inverters, and one got overloaded, and now that load fell onto the other 3 inverters, and they started going into error one after another, because the same high load is now, less inverters have to take care of the same load, and the load is high, and they started falling one by one, and it's very quickly the entire system went into shutdown. So what I learned on this job, even though Solarks allow stocking, we don't want to rely on maximum inverter output when you're stuck in those units. If you had just one unit, that would be no problem. If you just had one inverter, no problem. You would use the output to the load, as high as the inverter can put out. And for example, each one of those can do 63 amps maximum pass through. So you would just use, and then you would get to 63 amps, and then the inverter will shut down. So with one inverter, no problem. But when you have more than one, it's not like you can do 126 amps, because it is possible that if we're trying to draw 126 amps at the same time, one of the inverters, the software might not catch fast enough and one of the inverters might be trying to push 60 amps, and the other one will be in a 66, and it will send that inverter into shutdown, and now we have 126 amps trying to go through a second inverter, so immediately we will lose the entire system. So if you have a situation like ours over here and you need to stack Solarks, make sure you have enough bandwidth left on your capacity to allow high loads to come on and not overwhelm any one of the individual units. So do a design. When you're doing a design process, look at your loads and look what are the high loads, and make sure that in no situation you're going to have this scenario when a single high load overwhelms a single inverter and then just topples them all one after another. Right? So what we had to do over here, we added a fifth inverter. This way we never gonna have more than 5 or 6 kilowatts draw out of any unit. So we can pass through 9 kilowatts or no problem, right? Because each one of those units can pass through. Actually, continuous pass through is 7,560 watts, right here. So we don't want to get to that place. We don't want to be at 7,560. In our case, because we have 5 units, we're not going to have any one of them over 6 kilowatts, because now we distribute in this way. So let's say all 5 of them drawing a lot and then a high load comes on, we're not going to push over 7.56 kilowatts and create a shutdown. So that's one of the things that I learned, and I hope this will be helpful for you guys who are trying to do a Solark design for large commercial installations. Another thing, definitely do a bypass like I described. The bypass is simply gonna save you a lot of grief during the initial startup, maintenance, testing. You will have need to turn things on and off. You want to be able to give your customers an ability to use power while you programming the system, testing it, programming it, verifying that everything is smooth and working. Or later when you go away and you know it's your weekend or you're on vacation, there is no situation where your customer or your facility was left without power, and people need to, you know, it's a critical situation. So bypass, whether you do this kind of bypass or transfer switch, whatever strategy you use, do have a bypass mechanism available. Another thing that we did on this in this installation, we mounted our raceways directly to the inverters, and it worked really well on this installation, and now I like it very much. We just have pass-through bushings, and they go directly into the raceway, so we don't have any kind of conduits. Enormous saving of time, and you don't need to push wires through the conduits. We did a template, you know, we got the raceways, pushed it up against the inverter, marked all the holes, did the knockouts, and then used the pass-throughs. So makes much easier wiring, much easier job with the raceways. I think that's it on the Solarks. there was an existing battery bank with solar edges. We added a couple of BUIs and a new Solar Edge Hub HD wave inverters. I am going to tell you the truth. I am very biased about Solar Edge. So if some of you like Solar Edge, good for you. I'll be very honest, nothing but troubles. Solar Edge have had troubles before the installation, during the installation, and after the installation. Brand new BUI just burned, exploded after it was commissioned by Solar Edge engineer. Communication errors all the time, inconsistencies all the time, and this is not just on this site. Solar Edge, in my opinion, it's just a trouble product with lots of limitations. It wasn't my choice, and I would not recommend it. I would not recommend it. Technical support or customer support, it's very, very difficult. Sometimes you have to wait for hours and hours to get support, to get parts. It takes enormous amount of time. Again, if you love in Solar Edge products, don't judge me. It's your choice. I can talk from my personal experience and an experience of many installers. Solar Edge is unreliable, troublesome product with extreme amount of limitations. And what you can do with that, you have to jump through hoops and loops to make it work. And on a brand new system that was just installed, I'm seeing often that the failure rate is extremely high. So personally, for those who are looking for an opinion, I see Solar Edge equipment failing left and right on a regular basis. New equipment programming is a nightmare. Definitely not user-friendly, and not customer-friendly. For installer, you have the app, which is buggy, extremely buggy, extremely difficult, not easy to program. I think there is no comparison. There is no comparison in performance, no comparison in installation. Especially when we compare it to Solark or PalmCube, there is simply no comparison. Solar Edge just can't do a fraction of what Solarks can do, or what the PalmCube can do, or other manufacturer. Yes. Look at this. One of the examples. This is the Solar Edge inverter. Yes, they made it light and compact, easy to hang on a wall. But this area over here, this is all the wiring box. No thought about the installer. This box, this is just plastic. It could be easily a little bit bigger, just few more inches bigger, but no, they cramped it so badly that there's no space for wires, no space to work comfortably. Very difficult to get all the wires in. Very difficult to do all the communication wires. You're working with the tiny little wires in a cramped space. Just bad design. And this is their latest and the greatest units. The design from a standpoint of installer, it's not good at all. And this plastic will not survive. When those units living outside, those plastics, they get deteriorated very quickly. So enough about Solar Edge. By now you probably got my opinion. I'm strongly opinionated mainly because they don't work well. They fail all the time for different reasons. Compared to Solarks, if you install them correctly, they just work. And what they can do, you can hook up the generator, battery, everything, and the battery agnostics. So you can put any 48-volt battery and it will work. SolarEdge works with LG, and though they're not even working well with each other. So, and again, sorry about long story, but you got my opinion. I will not recommend SolarEdge because they just can't do a good job. Solark, definitely a great option. You also might see in my other videos that I'm a big fan of PalmCube, and right now PalmCube cannot stock inverters easy enough like Solark can. Well, PalmCube you can do that, but it's not as simple as the Solarks. They just get linked with the communication wire. With the PalmCube you need to do a little bit extra work and additional components. So if you're trying to back up large loads, Solark at this point is better. I know PalmCube, they're working on new system where you will be able to potentially stock up and link bunch of inverters together, and they will distribute the loads. But for now, you kind of have to create separate critical load panels and not back up one large panel. So this is probably enough information about this system. I hope you enjoyed, and I hope I was able to provide you some tips and help you with your installation of a Solark system. You obviously welcome to reach out to me in comments if you need some feedback, or if you have questions about this installation or in general. Thank you guys. Again, this is Sasha with Harmony Air, Northern California.